Thank you. It's good to be here. I'm Mantha. I'm the Artificial Intelligence Platform Leader at Sirius, where I own the vision and strategy for AI and machine learning. I'm also an applied machine learning architect, so I design and build machine learning applications. We're really passionate about building artificial intelligence solutions that work for everyone and augmenting processes with scalable machine learning so that human systems can focus on innovation and delegate the mundane. So today I'm really excited to be here and to talk to you all about something that I love doing, and that's conversational AI and NLP. So I want to start by doing a quick overview of NLP, which I'm sure we're all very familiar with here, and then we'll dive right into the problem space, which is what we were implementing last year. We'll talk about the tech stack that we employed, some challenges that we saw before going into production with just deployments, and also issues with NLP with respect to entity disambiguation. And then we'll take a look at some results and then open it up to questions. So, NLP and conversational AI is definitely not something new. It's not a new concept by any means, but conversational AI and machine learning have been experiencing a renewed focus in recent years. And I think that's because we're at a seminal moment in computing. If you take a step back and think about it, computing, or the history of computing has always had major shifts every 10, 15 years or so. It all started in the 1980s with a personal computer. It really changed the way that we interact with technology. Then, 10 or so years later, the internet arrived. I know, that looks pretty bad. So the internet is arguably one of the biggest changes in our lifetime, right? It democratized technology and information. It changed the way that we do business. It revolutionized industries. And, it just totally changed a lot of things. And 10 or so years later, the smartphone arrived. Now, the smartphone led and continues to lead a radical shift in the way that we interact with technology and in the way that we interact with one another. We're at another such moment now, where we're moving from a mobile-first to an AI-first world, where we're going to be seeing people interact with technology in ways never seen before. Now, what does it mean to be AI-first? I think it means that we're talking about technology that you can naturally converse with. I think it means that we're talking about technology that is thoughtfully contextual. It learns and remembers things about you. It doesn't have to be reminded of it each time. And it's able to offer a personalized experience for you. And I think it means we're talking about technology that learns and evolves and gets better each time. It gets more intelligent with each iteration. At the heart of all of this is NLP. Now, NLP is something that you need when you're working on building a performance search engine, to auto-classifying documents and invoices and stuff like that, to spell check, to autocomplete. Basically, any text intelligent application needs NLP. So it's a really exciting and really amazing area to focus your research on, and I think that's why it naturally fascinates a lot of data scientists and machine learning engineers. So here's our problem space. We wanted to implement a contextual assistant that augmented our IT and help desk team's capabilities. So essentially an assistant to drive up employee self-sufficiency that answered basic questions about routine technical issues, things that the help desk team typically deals with. But we wanted to go a level above that, and go beyond simply answering questions, because any rule-based bot can do that. We wanted to build a contextual assistant that could go beyond answering questions, because it's cool if you have a bot that can answer questions, but when you can actually get a contextual assistant to perform tasks on your behalf, to actually do things for you, that's when you start to add true value to any engagement. So we focused on purposeful automation. We looked at things that users and employees and people typically find useful, repeatable processes that we could automate. So things like opening a ticket. So we integrated our bot with certain external third-party services like ServiceNow, Outlook, and things like that. So the bot could actually do things like opening tickets, notifying stakeholders, escalating up the escalation chain, and so forth. And then we wanted to go a level above that and provide intelligent, smart recommendations to enable real-time and better decision-making. So we're still working on this, but we got the bot to actually do things like, hey, it looks like 80% of your colleagues have upgraded Microsoft Office this weekend, and they've reduced, a lot of latency issues. Do you want me to upgrade for you? Delegate the mundane so you can focus on innovation. So when we were, focusing on trying to surface this type of right information at the right time in a channel that people actually use, so in the right channel, we started seeing some issues with entity disambiguation. So what that means is, let's say you're building a travel assistant and you want to say, I want to book a flight to San Francisco, or I want to book a flight to Chicago, and you don't necessarily specify the source entity, you just specify the destination entity. Or if you were to say something like, hey, I'm on my cell, I can't talk right now. Cell here could mean lots of things, right? It could mean a biological cell or a cell phone, and traditional neural networks typically they don't have a whole lot of context to go off of because they're stateless, so they don't have persistence. But human beings, you and I, when I say I'm on my cell, you probably know what I'm talking about because our thoughts have persistence. But LSTMs, recurrent neural networks, attention models, transformers, their networks have loops in them allowing information to persist, so they're able to store context, which is why we started looking at CRFs, LSTMs, encoder-decoder models, language models, transformers, and so forth. And we zeroed in on Bert. Now, Bert is a pre-training NLP technique that was released by Google, and this time last year when we were looking to implement this, it was really state-of-the-art. A lot of people saw promising results with it, so we thought, cool, why not? We'll go ahead, use Bert. And one of the cool things about Bert is that it has this ability to pre-train bidirectional contextual language representations modeled on a large text corpus. And as a result, this pre-trained BERT model doesn't need, it only needs one, it can be fine-tuned to have just one additional output layer. It doesn't need many. And with that, you can create state-of-the-art models to do language inference, question answering, auto-suggest, and named entity recognition, and other downstream NLP tasks. So we leverage BERT specifically for NER, or named entity recognition, and auto-suggest. So I want to show you how we integrated our pipeline with BERT. I should say that we use the Microsoft Bot Framework as our enterprise chat framework, and we integrated that with RASA, so we used RASA for NLU. And RASA really gives you a way to cherry pick all of the entity components that you want to use. So you can use duckling, entity extractor, you could use CRF, you could also use like an entity mapper, which can map known synonyms. So we took advantage of RASA's flexibility here, and then we customized it to include BERT within our pipeline. Now I want to show you how BERT its results and then compare it to other language models and other extractors like Stanford NER or NER CRF. So before we do that though, I want to be mindful, this isn't a complete comparison by any means. Our use case ranging from HR to IT to a travel bot, we tried it out with a lot of data and a lot of really intuitive conversation, and it seemed to work in our use case. But obviously Spacey and Stanford NER are great models, and you should take advantage of all of them. So I want to show you this. Oh, and I also want to mention that this custom BERT component that was added to the NLU pipeline, it was a wrapper to the BERT service. Because I think some of you, are familiar with this, BERT does have some performance issues, right? So when you're trying to load BERT, the response time is somewhere between 5 to 6 seconds, and that sort of latency can be unacceptable when you're talking about conversational AI or really most operations. So what we did was we added this as a wrapper to point to the BERT service, and then the service was loaded to memory, so that was a workaround for us to get around the request processing. So that the first request was somewhere between 5 to 6 seconds, and then every consecutive request was almost instantaneous. So this is BERT, and we're looking at like a travel bot. So if you wanted to say, book a flight to Munich. So as you can see, it was able to recognize the entity. But now let's take a look at NERCRF. And you can see, as you can see here, it wasn't really able to recognize the entity here. And then now we're going to take a look at Spacey, which is also like a really cool model, and it wasn't able to recognize the entity when you use the same example and you said book a ticket to Munich. So that's the results that we saw with Bert. So we were really happy with the way that it solved for entity disambiguation and some of the other things that we looked at. It's a performant model, and with the workaround that we had, the request processing time was also pretty low. And now I want to show you the end result, right? Which is a custom, contextual travel assistant that can really deal with messy human behavior. So language is messy. There's 40,000 different ways you can ask about the weather. One of my favorite ways is when people say, is it going to rain cats and dogs today? So how does your model account for such complexity? Well, you do that by making sure that your model can look at context switching, both narrow and broad. You want to do that by ensuring that your model can handle chit-chat and things like that. So this is a travel assistant, and it's going to ask you a few questions in order to get some information so it can book a travel experience for you. So it wants to know where you're going, when you're going, and who's going with you. And so users will say, yeah, it's just me, but then they'll change their mind. So think of it in the context of like, an IT or a help desk bot. People will say, yeah, I want to open a ticket, and then they may change their mind. Or, in the financial sector, people will say, here's my account number. Oh, actually, no, that was a wrong account number that I gave you. Here's the correct one. So you want to be able to handle corrections. You also want to be able to handle narrow context, which is, the assistant asked, where do you want to go? And then the user said, why do you want to know? People will say, why do you want to know my account information? Why do you need to know this? So you want to be able to handle that, especially if you're thinking about using conversational AI to augment certain teams' capabilities. You want to be able to handle this sort of messy and not always a happy path, unhappy path sort of scenario. So it was able to answer why it needs to know that information, and then it nudged the user back onto the happy path. So that's really what you want to do. Okay, and then after we got the bot to really be able to handle chit-chat, corrections, both narrow and broad context, and messy human behavior, we played around with natural language generation. Now, NLG is like a really new and cool space, and a lot of people are doing a lot of good research with it. If you guys have, if you've been to the Chatbot conference in New York, you may have heard Sander Wubin give a really informative talk on natural language generation. And a lot of really intelligent and talented people are focusing their efforts in Bayesian program synthesis, or this concept of idea learning and transfer learning and reinforcement learning and stuff like that. So we played around with NLG. If you've looked at OpenAI's GPT-2 language model, you may be familiar with some of this. So I tweaked that language model to generate, natural language. And because we're still trying to solve this problem of generality. NLP, I think one of the biggest problems today, or one of the biggest areas of focus today, is not necessarily accuracy, because, it's very important, but a lot of models are accurate now. We're trying to solve the problem of generality and scalability. So NLG is not at a place where it's generalized. You can't necessarily use it. For instance, a legal bot, you definitely don't want to have your bot give legal advice. Or if you were here yesterday at the RASA conference, you may have talked to Tiago from Uper, and he's working on a really cool emotional contextual assistant. So you probably can't use NLG for that, right? But I used it just for chit-chat. So it was able to respond back on its own, and it's somewhat relevant, although it didn't say the type of music that it was into, it was able to recognize that, and then, engage in small talk. So NLG is really cool. We just played around with it for fun, and this bot is something that we were working on for research purposes. So once you have a really solid architecture, you have performant NLP that works, you're able to user test it, because with conversational AI, you want to be able to user test as much as possible and as often as possible, and don't wait until your bot's perfect to test it out, because you're never going to get to a perfect bot. It will always have flaws, but you want to be able to user test your contextual assistant. So once we did that, we were and the contextual assistant was able to answer questions, it was able to do things on your behalf, it was able to offer personalized recommendations. After we got there, we thought we were ready to go to production, and we wanted to go to prod. And obviously, when you're deploying any kind of software application, and you are going to production in an enterprise setting, there are lots of challenges involved. And we faced a lot of those same challenges as well. With conversational AI, it's a little more complex than that. So we obviously followed best standards and practices. We wanted to use CI/CD to automate our deployment because we were going to production almost every day. And we coded with security in mind. So we made sure that we were handling the keys and certificates and personally identifiable information, carefully and in a way that adhered to best practices and standards. But as we stood up this one contextual assistant, we wanted to stand up some more because we found some more use cases. So we really wanted to automate that entire process of going to production. So we built our own service called Scone, Serious Conversational Experience. And Scone, it starts with initializing a Git repository, and then it gives you a way to automate your CI/CD pipeline. It creates those configurations for you, and it hooks into any chat framework. So whether it's Microsoft stuff or Rasa stuff, it hooks into that. And if you're using Kubernetes to package your bot, what we did was we used Kubernetes and AKS to package it, and it auto-generated all of the Kubernetes deployment files. So this is something that saved us all a lot of time when we were working on this, and made things easier when we stood up additional conversational AI. So once you go to production, actually, I want to show you a quick video of Scone and how easy it can be to bootstrap a contextual assistant. Now, this is specific to the bot framework, to Lewis, but like I said before, because we're using Rasa for some of our NLU stuff, we plug this into Rasa as well. So you'll see that it's pretty easy. It's going to ask you a few questions, and then bootstrap a bot, create the project skeleton for you, initializing the Git repository and stuff like that. And there you go. So again, if you were here yesterday, you would have heard the importance of interactive learning and really testing your bot and making improvements as you go along. So one of the key things is when you deploy, you have access to all of this really valuable real user data. Of course, you have access to some of it when you're user testing, but we started by storing and tracking all of these conversations, and we used all of that data to learn from it to make our contextual assistant a lot better by learning from these mistakes. And then we trained our model, we added some more happy and unhappy paths, whatever was applicable in that sense. And we noticed a pattern with the feedback that we were getting, because we asked users for feedback when we were testing our contextual AI. So users typically, when they did give feedback, they would either say, hey, I asked you about how to download Zoom, but you told me what Zoom is. So it's not really relevant. So we wanted to fix some of those irrelevant answers. And then there were cases where the bot simply wasn't able to answer, which I'm sure you're all familiar with. And if that fit within the scope of our use case, then we added those answers. And then we would get requests for new features. So, hey, thank you for the ServiceNow link, but it'd be more useful if you actually opened a ticket on my behalf. So if we got enough of those requests, then we took that into consideration, and then we added that particular integration, and we got the bot to perform that particular skill. And of course, we trained and retrained our model and put it back into production. As we were doing this, we really wanted a way to continually test both linear and nonlinear conversation. We wanted a way to track all of the user conversations and visualize them. And we also wanted a way to plug that into our CI/CD pipeline so we could run integration tests before and after. any kind of deployment. So we built our own training and operations manager, and as you can see, it allows business to really visualize all of these metrics, track the things that are important in conversational AI, like total number of users, user retention, abandonment rate, and things of that nature. And Tom is also an end-to-end holistic tester, so that's what we really wanted to focus on, a way to automatically test and generate test scripts. So we use this to really make the process of continually monitoring and improving your conversational AI a lot faster. So at this point, we had performant NLP. We had a contextual assistant that could go beyond answering questions, but actually doing things and offering proactive advice at the right time. We made sure that we continually tested it and improved it. We were deploying to production each day. And so we know that a lot of things go into conversational AI, right? There are a lot of things that make it successful, like performant NLP, seamless integration with APIs, purposeful automation that actually solves what users want, that needs solving, and building a custom domain knowledge base that's relevant to your industry, your vernacular. So with all of these pieces, we got a little bit better at deploying, maintaining, and improving conversational AI. But it was a really exciting project to work on. We learned a lot, and we had a lot of fun doing it. So I look forward to hearing more from you and learning a lot today. So thank you.
Thank you. All right, we're going to do fast fire. First 5 hands I see up. 1, 2, 3, 4. Can I get a lady? Any ladies? All right, 5. All right.
Hi, so I see you're using GPT-2 and other languages for small talk. How do you see that being implemented for specific contexts in the future? Or what barriers are there to being able to do that?
Specific context, you said?
Yes.
Yeah, that's a really good question. I think that's something that a lot of us are focusing our efforts on right now, is how do you use a language model that's modeled after an entire Wikipedia corpus text and make sure you stick to context. But GPT-2 with a PyTorch implementation will still be able to identify intents and respond with what it knows. I wouldn't necessarily recommend using it for just any use case. We thought it would be okay for small talk because we can't really validate a lot of the information. But I would start with maybe deploying it as a pilot project in one particular use case, make sure you validate that conversation that flows through, and make those improvements. But yeah, that's something that we're all trying to solve. But yeah, great question. Thank you.
Hi, I have 2 questions. My first question is, does your framework work with Dialogflow?
We haven't tested our implementation with Dialogflow right now, but it should be able to, because we were able to plug it into the Microsoft Bot framework pretty easily.
Okay, great, thank you. My second question is, does the framework include any performance testing capabilities against the training data?
You're talking about Tom doing performance testing?
Right.
We're only testing the conversation aspects, and we have certain unit testing frameworks and TDD, BDD suites that we use outside of Tom. But in terms of load testing, Tom does not include that. Okay. But that would be a feature that we're looking to add.
Okay, thank you.
Yeah, thank you.
Number 3.
Hey, my question's going to come in a little bit of a tangent here. I work in a very large OEM, automotive OEM, so I have an executive and sort of internal customers we need to convince. A lot of the work that you're doing is analogous to the work we do as researchers, but then it's always difficult to communicate the progress of the work to the executive. So is there anything within your improvement pipeline that could actually communicate to the executive level? To convince them essentially about a specific voice or chatbot related project?
Yeah, we've worked on voice implementations. We've worked on use cases where you just keep it very high level and speak to executives in terms of reporting and stuff like that. But as of right now, if you're talking about Scone or Tom, in addition to just high level metrics, which you saw there, Tom itself does not include that type of reporting capability at the moment.
Number 4? Who is number 4 at?
I have a quick question. Can you elaborate more about your testing? Is it more unit testing or end-to-end testing or model testing? And generally, what you suggest is the best way to test like conversations, make sure the flow is not disrupted with your last changes and things like that?
Yeah, good question. So right now we're doing end-to-end testing of the entire workflow. And we're also doing testing of linear conversation, which is just question answering. And then we're testing nonlinear conversation, which is dialogue. So Tom will generate lots of combinations and permutations of where a dialogue could go. It will loop through some of those happy and unhappy paths and test all of those and validate them. And if the answer matches what it expected, then that's a pass. And if it doesn't, it's a fail. And then we look into that. We look into why it failed and make those improvements right there. So those are some ways to test. I'm sure, user testing is very important because we're still talking about conversational AI which has a lot of human intervention. We want human systems to still retain agency, and we're only automating and, delegating things that are repeatable, right? So I think user testing is very important. I would say, test it as often and as much with real users as possible. And of course, if you're talking about testing software applications, then, some of the applications that we've worked on, we've used unit tests and integration tests, Mocha, Chai, Jasmine, stuff like that.
You touched for a moment on the feedback that you get from users, and specifically you kind of hinted at mismatch of intents, right? So I was wondering what you do to try and sort of mitigate negative experiences for people who have that mismatch, right? Like, so you're getting data when the mismatch happens and they say, hey, that's not what I meant. But what sorts of conversational elements do you use to try and make the user feel a little bit okay about what just happened?
Yeah, great question. And I'm sure Dustin Dye is going to be up here a little bit later to really inspire us all about the importance of writing good copy and dealing, and failing gracefully and dealing with all of those fallbacks. So when you get an irrelevant answer and you were to say, and if the user says, hey, that's not what I meant, that's not what I asked you, we have like a fallback mechanism added in there to say, oh, I'm sorry, can you rephrase your question or something like that? And then they try again, and hopefully your contextual assistant is able to answer it. If not, another round of fallback. We typically do 2 or 3 levels of fallback, and then at that time, if your contextual assistant has to be routed to a human, we'll say, this person can, take care of you, I'm sorry for any inconvenience or something like that. That would be one way to do it, and that's why I think monitoring your conversational AI, all of the user conversations that happen every day is very important, because you want to be making those continual improvements. And if large unsupervised models obviously learn after you stop teaching them, but you still want to validate them. And if you're talking about supervised models, then it's going to stop learning when you stop teaching, so it's important to continually look at them and test and improve them. But yeah, writing good copy is vital. Like you saw, NLG, we're not really going anywhere with it right now. We're not close to solving the problem of generality. So I think that writing really good conversation is very important to ensuring that users have a good experience. Because if they don't like what they see, chances are they're not going to come back and talk to you about it again.
Round of applause for Mady.